Scatterplots and trend lines. Independent variable is your x, a variable whose value determines the value of the dependent variable. Dependent variable, your y, is a variable whose value depends on the value of the independent variable. So you can think of something like an equation. If I had y equals 2x, my x value would be my input, and that's considered my independent because I can pick whatever x value I want. And when I insert that value into my equation, 2 times that value, let's say 3, that will depend, my answer depends on what I put into the equation. So that's why it's called dependent. So independent is what I input into the equation. Dependent is based off of my answer, depending on what I put into the equation. Trend line is a line on a scatter plot drawn near the points. It shows a correlation or relationship which can be positive, negative, or neither. Line of best fit. The most accurate trend line on a scatter plot showing the relationship between two sets of data. A good trend line is a straight line that comes closest to the points on a scatter plot. We can use a trend line when the line association is linear. Linear means a straight line. A good trend line has approximately the same number of points above and below the line. So we have our scatter plot, and as you can kind of see, it's linear, right? So it's going on a downward trend, and they're pretty close to each other. So that's why we call it linear. So we can draw a line through the scatter plot. And when you're drawing that line, you want a same amount approximately of points above and below the line so that it's evenly distributed. And you can only have it evenly distributed if it's linear. Correlation is a measured relationship between two variables. Our variables are x and y. So if I was to draw a trend line, I would draw my trend line. Maybe that's not even that great. Let's try another one. This would be my trend line. So from left to right, I'm moving upward, and that's considered a positive association. And then on my next one, from left to right, I would be going downward. Therefore, it is a negative association or correlation. And then here, there's not an upward or a downward trend. So this is no association or correlation. You're going to hear the term association and correlation. Those are interchangeable terms. So correlation, association, you're going to hear those interchangeably. Positive correlation as the independent. So as your x variable increases, so as your independent variable increases, the dependent, which is your y variable, also will increase. On a negative correlation, as the independent variable increases, so as my x increases, the dependent variable will decrease. So they're not working together. And then lastly, a no correlation is there is no relationship between the independent variable and the dependent variable. So I just want to point out on a positive correlation, they have to be working together. Sometimes your correlation, they can both increase. But on scenarios where they're written out rather than graph, they can also both be decreasing in value. So if they are working together, that is considered positive correlation. On a negative correlation, one has to go up while the other goes down. So it doesn't matter which one's going up and which one's going down, but they cannot work together. So they're working against each other. So positive is when they're working together, negative is when they're working against each other, and the no correlation is there's no connection between the two types of scenarios. So here we have create a scatter plot. So we're going to take our ordered pairs and create them into a table. So -2, 6, 0, 4, 1, -1, and 4, -4. It says complete the table and graph the points. So we got -2, so left 1, 2, up 1, 2, 3, 4, 5, 6. Got 0, 4, so I don't go right or left. I just go up 1, 2, 3, 4. And then 1, -1 goes right 1, down 1. 4 to the right, 1, 2, 3, 4, and then down 1, 2, 3, 4. So from there, you can see this sort of a trend happening with my graph. It's going downward, right? So determine the type of correlation that would be called a negative because it's going from left to right, it's going downward. Okay. Jeremy conducted an experiment in which he recorded the number of seconds it took groups of people to line up in alphabetic order. His results are displayed in the graph. What type of correlation is shown by this data? So sort of like we did earlier, if we see the trend from left to right, it is moving in an upward trajectory, so that is considered a positive correlation. Identify the independent and dependent variables. So my independent, remember that's my x values, are considered your number of people. And then you have your dependent, which are your y values, and that is the time, and that's specifically in seconds. Okay. Making predictions. Predict the time it would take for 18 people to line up in alphabetic order. So the best way to make a prediction is to make a trend line. So remember what we talked about. A good trend line is we want about the same number of points above and below. So I have 1, 2, 3, 4, 5, 6 below, and 1, 2, 3, 4, 5, almost 6 above. That's how I know that's a good trend line. So to make a prediction, it says 18 people. So I'm looking down here is my people. So I'm looking for 18, which is about here. So I'm going to take this up to my trend line and I'm going to get about here. So I want to know about how much time would that take? Well, the time is on the Y. So I'm going to kind of estimate somewhere around here. So almost to 130. So I'd say about, so use that little squiggly line. I would say about 128. So if you said between 125 and 130, that would be a good answer. And seconds. Next one says predict how many people would line up in 90 seconds. So we're going to look for our seconds at 90. So here's 180. So 90 would be in between there. So I'm going to try to stay about halfway there until I get to my trend line. My trend line's here, so I'm going to see where did that line basically come out. So almost between 10 and 15, so it's a little closer to 10. So I'm going to say about 12 people. So your trend line is super important because you want to make sure that your point would be somewhere in the vicinity of the trend that's happening with the scatter plot. Example 2, the scatter plot below shows the number of calories burned during different amounts of exercise. The equation of the trend line is y equals 8x. So they gave the trend line, they created some points and wrote the equation for you. That's very important because if they have an equation, that's called the line of best fit. Okay, so that line of best fit is going to help us to answer questions when we have to input. It says in the equation given, what does x represent? Well, x is down on the bottom, so that means it is our time in specifically minutes. In the equation given, what does y represent? So y are the calories. How many calories would we predict to burn after 100 minutes? So rather than using our trend line, since we already have up here our equation, which is y equals 8x, we're going to use the equation, our line of best fit. So 100 minutes. Minutes is our x. So x is 100, right? So we want to input 100 into x to find our output or our dependent. So y will equal 100 times 8, which is 800. So my answer is about 800 calories. Then the next question says, how many minutes would we expect to burn 650 calories? So 650, that is our y value. So we're going to take our equation that they gave us, and we're going to plug in 650 for the y value and find the x. So we're going to have to divide both sides both values by 8, and that would give us about 81.25. So I'd say about 81 minutes. Okay, example 3, Caroline recorded the cost of different weights of apples and made a scatter plot of her data. Use the scatter plot to answer the following questions. What's the slope? So we have a trend line here, but if you notice, we don't have very many points that actually hit on top of the trend line. So this one's close, it touches it, this one close, but it also is at an intersection because I need to have intersecting points in order to create that. So even though some of the other dots might not be on there, I can pick any points that are at intersections. It doesn't have to be a point on the scatter plot itself. It just has to be a point from the trend line because we're making an equation of the trend line. So we're going to go ahead and find our slope. So from 12 to 24, that is a rise of 12. And from 6 over to 12, that is a run of 6. So my slope is 12 over 6, which equals a slope of 2. Next question is, what is my y-intercept? So on the y-axis, we are at 0. Now we're ready to write our equation. So we're going to plug it into slope-intercept form. So y equals 2x. We do not put plus 0. Does the scatter plot show positive or negative correlation? So if I'm reading it from left to right, I am going up. So that is a positive correlation. Okay, predict how much it would cost for 80 pounds. So remember, we already had our equation, which is y equals 2x. And in this scenario, it says 80 pounds. Pounds is x. So we're going to just say 2 times 80. So y is 160. So my answer would be about $160. Next one, predict how many pounds you would get with $300. So again, our prediction, since we have a trend line equation, we're going to use our line of best fit. So 300 is our y value. So we're going to say 300 equals 2x. So we're going to divide both sides by 2, and that's 150 is our x. So about 150 pounds. So that should give you through your notes, and you should be set for that.